Today we're going to be using what are called properties of logarithms. And we're going to use these properties to either expand logarithms, so we're taking one logarithm and making it into multiple logarithms, or taking multiple logarithms and combining it or condensing it into one log. And one of the reasons why we may want to do this is because we have those properties of logs that we talked about yesterday, where like log 3 of 3 would just be your exponent, or in this case 1, because it's really 3 to the 1 power up there. So that's why we do this, because it can make life a little bit easier. So the product property, if I'm multiplying two logs, so I have log base b of m, see, m times n, and m and n can be any number or any letter. It can be anything. And our base is b. What this is going to equal is going to be log base b of m plus log base b of n. So notice that they're both log base b's, and I have two separate logs being joined by an addition symbol. And then we can go in the reverse. If I have two logs that have the same base that are being added, I can condense them into a single log that's being multiplied. So these equal signs that for all these properties means that we can go both directions with this. Now, division, you might have already guessed that this means that we're going to subtract. And again, the bases have to be the same. If the bases are not the same, then you can't condense them. Because we are subtracting, the order matters. The top numerator, whatever's in the numerator, goes first, then minus whatever's in the denominator. Minus sign, whoops. Whereas the previous one with the product property, we were adding, because with addition, the order doesn't matter. But I always like to put the first thing first, second thing second. It helps us for the quotient property where we subtract. Then the last one is the power property. So we have log base b of m raised to the n power. What happens here is that n, that exponent, actually comes out in front as a coefficient. So this is going to be n times the log base b of m. Base b still. And we have n. We don't want to do that. Here we go, in m. And the reason why we want to do that is because now we could divide both sides by either the log or divide by n. So that power property is something that is very useful. So like I said, we can go back and forth with these properties. All right, so let's look at these down here. We're going to expand the following logarithms, or the following log. So I have a couple things being multiplied. I have 3. I have x to the 6th, y to the 1/2. So this is going to be rewritten as log base 3 plus log base 3 of x to the 6th plus log base 3 of y to the 1/2 power. So notice that it was base 3, so all of these have a base 3. Oh, I need to go back and fix log base 3 of 3. So you notice that all of these have a base of 3. Now log base 3 of 3, we can type that into our calculator, and that's going to equal 1. Now with the next log base 3 of x to the 6th, this is an exponent, so we can bring that out in front. So it's going to be 6 times log base 3 of x. And then with the next one, this 1/2 can be brought out as in front as plus 1/2 log base 3 of y. So this would be your final answer because we expanded the log as far as we could. All right, then letter B, everything in the numerator I'm going to change to addition. Now, since there is no base written, it's an invisible 10. So this is going to be log base 10 of 7 plus log base 10 of y to the third minus log base 10 of 4 minus log base 10 of x squared. Again, because the reason why these two are both minuses is because those things came from the denominator here. And then we can simplify things. So let's leave this as log base 10 of 7. We can't do anything with that. This 3 can come in front. So plus 3 times log base 10 of y minus log base 10 of 4 minus, bring the 2 in front, 2 log base 10 of x. Now, if you wanted to write this without the 10 written, make that 10 invisible, you could do that. If you wanted to evaluate these in your calculator and then subtract them, you could do that as well, but we can leave it like that, and that is an expanded log. Then this last one over here, before I do anything, I'm going to change log base 10 to times m to the 1/3 over n to the 4th, because the third root or the cube root is the same thing as the 1/3 power. So now we're going to have log base 10 of m to the 1/3 minus log base 10 of n to the 4th. Bring the 1/3 in front. So we have 1/3 log base 10 of m minus 4 log base 10 of n. And again, we can say 1/3 log of m minus 4 log of n. And that would be your final answer. So basically, you need to remember that if we are expanding and we see things being multiplied, we're going to add logs. If we see things being divided, we're going to subtract logs. All right, I want you to try letter D and E down here. So pause the video, and when you're done, let's see what you get. All right, so you can see my work and my answers here and what I did to expand both of these logs. Now we're going to go in the other direction. We're going to condense the logs. So anytime that I see a subtraction sign, that log is going to go, or that other number will go in the denominator, and anything that's being added, those numbers will go in the numerator and be subtracted, and numbers in front or coefficients will become exponents. Now, with logs of actual numbers like letter A here, I know we can just type these into the calculator and evaluate it, but I want to get you guys practice simplifying them using these properties. So I'm going to do this exponent up here. So it's going to be log base 10, you don't need to write the 10, of 2 times 3 to the third, because we have a plus sign right here, over or divided by 9 because of this subtraction sign right here. So then we got to simplify this a little bit more. 3 to the third power is 27. 2 times 27 over 9. And that will equal log base 10 of 2 times 27 is 54. 54 divided by 9 is 6. So this simplifies to log base 10 of 6, which I know we can type in the calculator. Letter B, ln is log base e, so we're going to leave it as log base e though. Bring this 2 up. So we have the ln of 3 times x to the second power divided by y because of this subtraction sign. We can't simplify that anymore, so this is our final simplification. So I'm going to go ahead and do these two down here as well. So I'm going to bring this 2 up and bring this 1/2 up. So it's going to be log base 2 of x squared times, because of this plus sign, times y to the 1/2, which we can write as the square root of y. So this is going to be log base 2 of x squared times the square root of y. And that is our condensed log. Now with letter D, this subtraction sign means that this is going to go into our denominator. So we're going to have log base 5. This 2 is going to go up here. So 10 squared times, because of this plus sign, times 3 over 12. So log base 5. 10 to the second power is 100. 100 times 3 is 300 over 12. So we can simplify 300 over 12, simplify that fraction. Or you could leave it like that or make it a decimal. Let's see, if we simplify 300 over 12, that gives us 25. So log base 5 of 25. Now you might be saying, well, do I have to make this even simpler, because we know that 25 is 5 squared. So you could go and say, okay, log base 5 of 5 squared. And we know that that property, because these are the same, is just going to equal 2. If you can get to here, that's what today's lesson is about. But then you should be able to get to this part here where it just equals 2 based on what we did before. So it's really important that you recognize how all these properties of logs can fit together. Now on the next page, I want you guys to type these into your calculator, all the problems on this page, because we could use the properties, but like I said before, if we have our calculator, we might as well use it. So go ahead, take some time to type all of these into your calculator and see what you get. All right, so using a calculator, this is these are the answers that I got for up here. Notice that we can have negative values after we take the log. We can't take the log of a negative number, but we could take the log of something and get a negative value. Because remember, the range for logarithmic functions are negative infinity, comma infinity, meaning we could get a negative y value. And then these are the answers down here. Right? So that's it for this lesson. The main idea here is really these properties of logs. So make sure that you really know how to use them. So thanks for watching. Make sure to like this video and subscribe.